Hi, welcome to the second video on graphing a quadratic equation. In this video, we're going to see how to graph a quadratic equation that's given to us in this form: y equals a times the quantity x minus h squared plus k. This form of the equation is called the vertex form. And I just want to point out for now that that number a that's in front of the x minus h squared is the same a that's in the standard form. The standard form, remember, was y equals ax squared plus bx plus c. So if you start with a standard form and you do some completing the square on it, you'll get the vertex form. And I'll show you how to do that in another video. So in this video, we're just going to start with an equation in vertex form and see how to get the graph of the parabola from that equation. So first of all, the axis of symmetry of the parabola. So remember, the equation of the axis of symmetry when the parabola was given to us in standard form, the equation was y equals negative b over 2a. Well, here, if it's given to us in vertex form, the axis of symmetry is the line x equals h. And that's basically because when you will see when we do completing the square on the standard form, we'll see that h turns out to be negative b over 2a. And that's why it turns out that the axis of symmetry is just x equals h. So when you're given an equation in vertex form, you can just write down the axis of symmetry as x equals that number h. Okay, so let's look at an example. So in this example, this is lesson 20, the worksheet that goes with lesson 20, problem number 2, part A. It says graph the parabola y equals x minus 2 squared plus 1. So let's look at what a, h, and k are. So we can rewrite this as y equals 1 times x minus 2 squared plus 1. And we can see that a is 1, h is 2, and a is 1, h is 2, and k is 1. And that means, first of all, if we look at a, we know a tells us the position of the parabola, and so a is a positive number. It's positive 1, and remember that that tells us that our parabola is going to open upward. So keep that in mind as we sketch the graph, and if we see anything that doesn't look right, if we are getting something that opens downward, then we can go back and figure out where the mistake was. So we know in advance we've got a parabola opening upward because a is positive. So now let's see what the axis of symmetry is. So the equation is going to be x equals h, and in our case, h is 2. So the equation is x equals 2, and that's the vertical line at x equals 2. It looks like that. So that also tells us the x-coordinate of our vertex. So that's the first point we're going to find when we fill in this table. So the vertex has x-coordinate 2, and now to find the y-coordinate that goes with it, we're going to plug in 2 into the x minus 2 squared plus 1. So notice that 2 minus 2 is 0. So we get 0 squared plus 1. So we just get 1, which is, remember, that's our k. So the vertex is 2, 1. And it's always going to turn out that when you're given an equation in vertex form, that the vertex will always be the ordered pair h, k. And that's why we call it vertex form. So we didn't actually need to plug in x equals 2 to get the y-coordinate, but I wanted to show you why it turns out that k is always going to be the y-coordinate. So now we have the vertex. Let's get a couple other points. Let's get 2 points on either side of the vertex. So we're going to use two numbers less than 2, so the number 1 and the number 0. And then two numbers to the right are going to be 3 and 4. So plugging in 1, we get 1 minus 2 squared plus 1, so that's negative 1 squared plus 1, so that's 2, so the y-coordinate will be 2. Then plugging in 0, we get negative 2 squared plus 1, so we get 5 for that y-coordinate. So the point will be 0, 5. Now plugging in 3, notice that we get 2, so we get the point 3, 2, and when we plug in 4, we get y-coordinate 5 again. And that always happens if we choose the points so that we have 2 points on the left and 2 points on the right of the vertex that are the same number of units apart, because we have symmetry. So now let's plot those 4 points. And the last one, and connect them with a nice smooth curve. So we do have a parabola opening upward with the vertex 2, 1. Okay, so let's look at another example. So this one says graph a parabola y equals negative x plus 1 squared minus 2. So this is in vertex form, although it looks a little bit different. So it looks a little different from the y equals a times x minus h quantity squared plus k. So let's rewrite it so it's much more consistent with our vertex form. The vertex form, we want a in front, so I'm writing negative 1 to show what a is. And I'm going to write x minus negative 1 instead of x plus 1, and that's squared. And then I'm going to write plus negative 2 instead of minus positive 2. And that's because I want to identify clearly what a, h, and k are. So here we can see that a is negative 1, h is negative 1, and k is negative 2. We had to rewrite it a little bit to see that clearly. So now we can write the axis of symmetry. The equation of the axis of symmetry is x equals negative 1. So let's sketch that. There's that vertical line. Also, we've got the x-coordinate of the vertex. So the x-coordinate of the vertex has to be negative 1 because it has to lie on that line. But also, better than that, we even know the y-coordinate of the vertex. We know that the y-coordinate is k. So the vertex is going to be just the point negative 1, negative 2. So I didn't even really need to plug in negative 1 to get negative 2 for the y-coordinate. Okay, I'm plotting that point. There's the vertex. So now, let's find 2 points on either side. So I'm going to use negative 2 and negative 3 on the left, and 0 and 1 on the right. So when we plug in negative 3, we get negative 3 plus 1 squared minus 1. So negative 3 plus 1 is negative 2. When we square that, we get positive 4, but we have a minus sign in front, so negative 4 minus 2 gives us negative 6. So the point is negative 3, negative 6. So I want you to do the same thing with negative 2. Go ahead and put me on pause and figure out what that y-coordinate is. That goes with x equals negative 2. All right, so we're back. So we all should have gotten the y-coordinate negative 3. So the point is negative 2, negative 3. Now do the same thing with x equals 0. And notice the symmetry. We also get a y-coordinate of -3. And when we plug in x equals 1, notice we get -6. And that's because of our symmetry. So, plotting those additional points and labeling them. And connecting with a nice smooth curve. And there's our graph. Now, we should have checked in advance, we could have checked in advance that because A was negative, we knew that we were going to have a parabola that was opening downward. So we could have checked that in advance. But notice that we did get a parabola opening downward. Okay, so that's how to use an equation that's already given to you in vertex form to sketch the graph of the parabola. You can get the vertex, which is hk, the ordered pair h, k. You can get the axis of symmetry. The equation of the axis of symmetry is x equals h. And then just plug in a few other points on either side of the vertex and you get a nice smooth curve. All right, I'll see in another video how to transform an equation in standard form into the equation for the same parabola in vertex form.